Hi, and welcome to Chapter 3, Learning Objective 3. Today, what we're going to do is to take a look and use all the information that we have started in Objective 2. We're going to go ahead then and have these two countries trade. So without further ado, let me share my screen with you. And start my slideshow. There we go. Okay, as I said, what we're going to do in this chapter is we're going to really illustrate using the information from the trade table, using comparative advantage, how these two countries should trade. Okay, so here we have a kind of additional information that would be given to us in a problem state. Suppose the U.S. produces 3,400 tons of wheat. How many computers would the U.S. be able to produce with its remaining labor? Draw the point representing this combination of computers and wheat on the U.S. production possibilities frontier. Okay, so a couple of things just to remember from previous slides. Remember that we have 50,000 labor hours in the U.S. To produce one computer takes 100 hours. To produce 1 ton of wheat takes 10. Okay, so that's information that was given to us previously. And so now we're going to say that the U.S. produces 3,400 tons of wheat. So at this point, what we want to do is say, okay, we have 50,000 labor hours. But if we're producing 3,400 tons of wheat, it takes 10 hours to produce wheat. So that's 34,000 labor hours that we've used. If we have 50,000 that we can allocate, if we subtract 34,000, we end up with 16,000. It takes 100 hours to produce a computer, so I'm going to take 1,600, divide that by 100, or lop off 2 zeros. So the answer to this one is 160 computers. Okay, now there are different ways to get to it, and again, that's what's cool about math, but this is just, in my opinion, one of the easier ways to do that. Okay, so let's go ahead and put that on our graph. So again, 3,400 tons of wheat and 160. So we're going to say that the U.S. is going to produce here at point A. Okay, so here is our 3,400 tons of wheat, and here is our 160 computers. Okay. Now, suppose Japan produces 240 computers. How many tons of wheat will it be able to produce with its remaining labor? Well, remember, that was one of our endpoints that we had. When we drew out Japan, we said they could either produce 240 computers, and I believe it was 1,600 tons of wheat, I believe. I'm trying to remember. But we could use the same methodology. If they have 50,000 labor hours, to produce one computer takes 125 hours. To produce one wheat takes 25 hours, right? So we can take 50,000. Oh, I'm sorry, that's incorrect. I'm going to erase that because I got ahead of myself here. Go ahead and erase that. So we know to take 2,400 computers, we're going to say 240 times 125, and that is 50,000. So we don't have any remaining labor out. 30,000. Okay, so in this one, we can use the same methodology. Suppose Japan produces 240 computers. How many tons of wheat would Japan be able to produce with its remaining labor? Draw this point on the production possibilities frontier. There was a disparity in labor hours, because remember, Japan had 30,000 labor hours. To produce one computer takes 125 hours. To produce 1 ton of wheat takes 25 hours. Notice the big difference here. This is why we're making some accommodations for the U.S. That's why they ended up producing both computers and wheat, but predominantly wheat because that's where they had their comparative advantage. In your problems, this will not happen. Your labor hours will be the same. And so you just want each country to specialize in what it has a comparative advantage in and what it does best. So let's go ahead and take a look at this one using kind of the same methodology. So we have 240 computers, and it takes 125 hours to produce those. That ends up at 30,000. We have 30,000 labor hours to use. We've used all of them. So the answer here is nothing. So we're going to go ahead and draw that on our production possibilities frontier for Japan. Okay, now what I want to do at this point is to get a sense of how many computers do I have overall in the world population and how much wheat do I have overall in the world as well. So I'm just going to, I think maybe the easiest way to do that would be to look here at point A, right? And then remember that Japan, I'm going to put them over here. Japan has, if I can get over there, there we go. Japan has 240 computers. So let's get a look at where we're at in the world. So if we have computers and we have wheat, we have the US, we have Japan, and then we have the total. I'm just going to try to write it really small here. Computers in the US, we have 160 computers at point A, and we have 3,400 tons of wheat at point A. Japan has no wheat, but 240 computers. So we see that our total is 300 computers, and our total wheat is 3,400. So this is a gain. And remember when I said earlier, when we take a look at what the world can produce, it should always be greater than where you started. So the 300 is actually, I believe, 30 computers to the better because we had 270 to begin with. And the 3,400 is 300 tons more because we had 3,100 when the two countries did not know each other existed. Okay, bear with me because I'm going to come back to that point in just a moment. Okay, so we have our two ideas. Remember, export and import, we've already defined those. Now we look to the problem to ask how much of each product is each country going to trade, how much is it going to sell or export, and then how much of each product is it going to import. So let's go ahead and look at this. So suppose the US exports 700 tons of wheat to Japan and imports 110 computers, and Japan 700 wheat and 110 computers. Okay, so let's take a look at this. So remember, right now at our current state, we're producing, this is when the two know each other exists. We said we have, oops, that's incorrect. Let me take care of that. Okay. We have 3,400 tons. I'm going to put that right about there. 3,400 tons of wheat. And we have 160, I'm going to put it right about there, computers. So the US is now producing at point A. The problems will always tell you if you have some kind of accommodation to make. You won't have those accommodations to make because yours is going to work out so that ideally the US would just produce wheat, but we would end up with too much wheat and not enough computers if we allow that to happen. We also said from the previous slide that Japan is just going to produce computers, so they're going to be here at point B. All right. Now taking the information from our slide, so I'm going to go back here and pick this up. The US exports 700 tons of wheat to Japan. So if I take the 3,400 and I subtract 700, right, that leaves me with, and I think it's 2,700, but my mind is not wanting to work too well today. So I'm just going to double check. Yep, 2,700. So I'm going to go ahead and put this 27 right about there. And just to keep this graph clean, I'm going to come out here and I'm going to say 2,700. Okay, so that is The US exports the wheat. How much wheat does Japan have currently? They don't have any. So we're going to add 700 to that. Maybe right about there-ish. 700. So that's what happened with wheat. Okay. And now we have a corresponding payment, if you will. So so Japan is going to export to the US. I believe it was how much? 110 computers. So now right here we have 240. 240. And I'm going to subtract 110 from that. So that leaves me with 130. So approximately, I don't know, right about there sounds good. 130. So those 110 computers are being exported from Japan, imported to the US. Right now, the US has 160 computers. So I'm going to add 110 to that. Okay, and that gives me 270, right? So if 250 is right about there, 270 should be right about there. Yeah. Okay. All right. So at this point, we can see kind of what's happening. Okay. Now, this is the magical part, if there is such a thing, I think, here in comparative advantage. And yes, I've been known to put on a Harry Potter robe and kind of talk this through. But if we take the 2700 out and we take the 2700 up right about there, and we take the 700 and the 130, we end up outside of the production possibilities frontier. That's why, and this is like really wicked important, this is why trade makes everyone better off, because through using the principles of comparative advantage, which tells which country what to specialize in, what they do best, that a country, excuse me, a country can consume more than they can produce. And more so, they can get outside of the production possibilities frontier to a point that was previously unattainable. So this is why we say specialization, comparative advantage, and allowing countries to trade will allow a country to consume more than they can produce. It's the magic of it all. Where did those gains come from? So originally, we started off with, and this is when we ignored, okay, so without trade, didn't know the other country existed. We started off at the red dot right here. I'll call that point A. Okay, so at A, we produced 160 computers and 3,400 tons of wheat. Once we started to trade, we were able to import 110 computers. We were able to export 700 tons of wheat. And notice where we end up at. We end up at an amount 270 and 2,700. The wheat is less, but when we look at it in an overall world, we'll see why it actually is a better number to have. But my point here is the amount that we could produce was only 160 computers and 3,400 tons of wheat. The amount we can consume is way more computers. And we end up at this point, which is outside the production possibilities frontier, which was a formerly unattainable area. Let's look at Japan. Japan, they started off again without trade. One scenario for them was they could produce 240 computers. We actually cut them in half and said they were here. But once we figured out that they were a comparative advantage, they're going to move here to point B. And so they were able to import 700 tons of wheat export the 110 computers, and they end up with 700 tons of wheat, 130 computers, and they're at a point C, which was previously an unattainable area. So they're able to consume more than they're able to produce. So this is why we say trade makes everyone better off in the long run. Now, again, looking at a world perspective, how does this work out? So in the US, we have 20 more computers. We have 200 tons more wheat. And this is if we would have halved our labor force, right? We ended up saying, okay, we're going to put half of our labor force in computers and half in wheat. That's where these numbers came from, right? The 50,000. And then we divide that by 100. And actually, I'm sorry, that should be 25,000 because we're going to split the labor force, and 25,000 divided by the 10 it takes to produce wheat. That's where these numbers right here came from. I just want you to see that. And then in Japan, we did the same thing. We said 15,000 labor hours, half of their labor force, and they're just going to produce computers at 125, 15,000, and 25. And that's where the numbers in that first, the consumption without trade came from. I just want you to know that because sometimes in APLIA they ask you that. Our consumption with trade. Notice these numbers are larger. That will always happen in your problems. If you're ending up with lower numbers, you're doing something wrong. So where's our overall gains? Again, the US gets 20 more computers, 200 tons more wheat, 10 more computers in Japan, and 100 more wheat in Japan. So when we looked at this, we said, okay, who has an absolute advantage? Remember, the US had an absolute in both wheat and computers. But remember, absolute has nothing to do with trade. It just says who can produce the most. And obviously the problem was set up funny because the US had way more labor at 50,000, almost double. Okay, so the US has an absolute advantage in both goods, but when we looked at the opportunity cost and we used that idea of comparative advantage, we saw that these two could gain from trade as long as each have a comparative in the opposite good. So we said, and using the trade table, we said that the US had a comparative in wheat, so they predominantly produced wheat, but because of the discrepancy in labor hours, they had to produce some computers. And Japan had a comparative in computers. That's why we know that these two can gain from trade, right? So this is the important point right here. Absolute advantage is not necessary for a comparative advantage. Okay, that's the end of this learning objective. And we have one more short one, and then chapter 3 will be complete. Please let me know if you have any questions or if you'd like to see additional problems. I'm thinking I'm going to be putting up another problem just to make sure that you have a lot of practice. In fact, our next objective, that's really all it is practicing another problem. Thanks for your time, attention. Have a great day.